All right, this is section 13.3, log properties. Tonight's homework is page 745. We already did 10, 1 through 10. You're going to do 11 through 20. Remember that you have a quiz on Friday. That's going to be on section 13.2. So I'm going to give you expanding and condensing logs. And then also on Friday is your retake for factoring. It's your last chance to retake that test. And also, I promised you one more surprise factoring test for the end of the year that you cannot retake. And I want you to kind of put your thinking caps on. If Thursday is the only day this week that says review, what do you think is going to happen on Thursday? Okay, so keep in mind that this last factoring test is not retakeable. So anything that you still are not feeling good about for factoring, you definitely need to go to Our Power and get some practice in, because once you take this test, it's done. And then the retake is on Friday, and then pretty much after that, the only thing going in your grade is extra credit for Our Power, your stamp sheet for May, and your final exam. That's it. Okay, so you want to take advantage of these really big opportunities to boost your grade up. All right, we're going to do a few examples, and then I want you to start the homework, and then we're going to play a review game to make sure we're good for the quiz. Example 1. Let's say we have 3 to the x minus 2 equals 24. Te digo. Okay, so since I cannot write 24 with a base of 3, because 3 squared is 9, 3 cubed is 27, so 3 cannot be written with a base of 3 cannot get me to 24. Because 3 squared is 9 and 3 to the third is 27. 24 is in between these two numbers, so there's no number in between 2 and 3 that's going to get me, at least an exact number that's going to get me with a base of 3. So since I cannot rewrite 3 as a base, 24 as a base of 3, I have to use one and only one method. It's the only way to solve for an exponent, is to use the log. The only way to solve for an exponent is to use a log. What's the purpose of a log? What does it do? Solve for the exponent. So the only way to solve for an exponent, if the bases are not the same, is to just use my logs. So that's the only additional thing to think about today, is I want you to first see if one of the other sides can be rewritten with that same base. And I'm going to do a second example to show you when it would work. You would not need to use logs. I'll show you an example of that. Okay? But here you're going to need to, because I can't rewrite this 24 as 3 something. I can't. So I'm going to take log of what on both sides? 3. Log base 3. Again, I'm just re-showing you what we did yesterday. What do you get when you have the log base 3 of 3? 1. You're going to bring down that x minus 2, so you're just left with x minus 2 equals the log base 3 of 24. How do I rewrite this again? The change of base formula tells me that I can write which one on top? Log of 24 over the log of 3. We're gonna approximate that. Mina, what do you get, babe? What is log of 24 divided by the log of 3? Thank you. We're going to add 2 to both sides. X is approximately 4.89. Remember, you can always check your answer by plugging it back in. Please take your highlighters. And for example 1, I want you to write method 1. This is one way to do it. In fact, I would like for you to please go back and label this as example 1A. Because I'm going to do the same exact problem with the second method and show you that you get the same exact answer. Let's call this 1A. All right, let's do example 1B so I can show you that you get the same answer. Let me make sure I copy it exactly. 3 to the x minus 2 equals 24. One thing I do want to go over is the reasonableness of your answer. What is 3 squared again? 9, and 3 to the cubed is, doesn't your answer have to be in between that, 24? So you know your exponent has to be between 2 and 3? What is your answer again? And then subtract 2, what is that? And do you see how that's in between 2 and 3? So your answer makes sense. So you could always check, let's say you have the ability to have just checking on a calculator. Let's say you have 4 choices and you have to choose which one it is instead of you finding it. Then you would have to check the reasonableness of your answer. So you know your answer has to be between 2 and 3. Any questions on why your answer has to be between 2 and 3? Are you guys okay? Just tired? Okay. Method 2. Instead of taking the log base 2 of whatever, first you're going to do the exponent rule. That means you're going to take the power and you're going to make it a coefficient. So go ahead and highlight the power, which is x minus 2. And you're going to pull it down so that you have x minus 2 and then log of 3. Remember, the power rule just says you pull down the x minus 2 and then take the log of the base. And what you're essentially doing is taking the log of both sides. So when you log both sides, this is what you get. Now I just want to solve for x. This is still x minus 2 times some number. So if I were to take you back to algebra 1 real quick, how would you solve x minus 2 times 5 equals 15? What do you do first? Divide by 5. So what are you going to divide by here? Yeah, you're going to divide both sides by log 3. And then you have x minus 2 equals log 24 over log 3. Well, isn't that what you got in method 1? You ended up with that same statement, except instead of taking log base 3 of 3 and having to worry about it, you just logged both sides. So you're essentially doing the same thing, except you don't need that base 3, you just take the log of both sides. So here you get the same answer, which is 4.89. So x is approximately 4.89. And then this would be method 2. Now, a lot of kids my last year were like, Miss Riad, I don't really see much a difference between the two methods, and you're not alone. One says log base 3 of 3. The other one just says just take the log of both sides. Justin, fight it, babe. You're almost done. I just don't want you to be lost. We're only going to do a couple of more because you guys look really tired today. I don't know what it is. Example 2. Remember, I promised you an example of when you wouldn't need a log. So if you have 9 to the 3x equals 81. You could log both sides, or you could recognize that 9 can be written, this 81 can be written with a base of 9. How do you write 81 with a base of 9? 9 squared. So this is 9 to the 3x equals 9 squared. You don't need logs now. Well, if the bases are the same, then the exponents have to be the same. Everybody with me? If 9s are the same, then these have to be the same. There's an equal sign there. Equal sign means everything has to be the same on both sides. So if the 9s are the same, then the exponents have to be the same. Y'all with me? So that means that 3x has to equal 2. So x is equal to 2/3. I just want you to recognize when you're going to need logs and when you don't need logs. If I can rewrite the base to be the same, why do I need a log? You don't. Your doyo is to solve example 2 using logs and prove that you get the same answer. You guys fight to sleep. Whatever you gotta do. If you need to stand up, then you need to stand up. Come on, fight it. So your doyo is solve this bad boy using logs, either method 1 or method 2, and prove that you get the same answer. Oh crap, the makeup needs to go to the car. Damn it, I'm so sorry. That black bag. To the car, I'm so sorry. I thought I put it in that other bag. I'm sorry, baby. I thought I put that. Nah, that goes in here. But that black thing needs to go in the car. Check your answers with your group, please. Make sure you get the 2/3. Tara, what'd you do first, babe? Did you do method 1 or method 2? Okay. How many of you guys did method 1? How many of you did method 2? This is exactly why. This is an exact example of why good first teaching is so important. The first thing you're taught is usually what you remember, right? Even if the second one is just as good, we always tend to go with what's first. That's why when you learn something, it's critical that you learn it correctly the first time. It is really hard to undo. So I just wanted to show that to you. Driving, cooking, everything. Do it right the first time. Then your life is easier. What'd you do, babe? Okay. How about from here, Oscar?
It cancels out, so it's just 3x equals log base 9.
Jeremy?
Log base 9.
What do I put on top, honey? What'd you get when you did that? You guys, this right here, I should recognize the purpose of a log is to solve for the exponent. So 9 to an exponent equals 81. So what do I get? 2. That's why log of 81 divided by the log of 9 is 2. Juju, don't let me lose you, babe. So then I get 3x equals 2. It's actually an equal sign, so x equals 2/3. Last example, and then you guys can do tonight's homework. Example 3. Everybody should have the homework in front of them, by the way, so that when I ask you to write your summary, you are ready to go. Sean, what should I do first, babe? How come I can't log it up? Remember yesterday? What has to be true in order for you to be able to log it up? Maybe this will help? Yes. The log, the exponent has to be isolated, Brandon. This is what we went over yesterday. You're not allowed to take the log of both sides if all this other extra stuff is around it. So you got to get rid of that -5 first. So we're going to add 5 to both sides first. Andrew, what do you do after this? Now can I log it up? Now can I take the log of both sides? Okay, would you like to do method 1 where I take the log base 11 of 11? Or would you like to do method 2 where I just log both sides? 1? Alright, sure. So log base 11 of both sides. And what do I get, Angelica? What happens here? And what do you left? Huh? Yeah, what are you left with? And what are you left with? Good. Jason, now what? Okay, I think you guys are getting the hint. Good job. Marissa? What is log of 31 over log of 11? 1.4? I didn't hear you, sorry. So x plus 2 is approximately 1.4. Priscilla, last step. And what is that? .56? Okay. It's approximate, so you're good. Give me a summary, please. Today I learned